All right, we're going to switch this up a little bit. Thought about it, and we already have a chance to divide by an x squared minus 3x plus 5 down here. So let's go ahead and change what we're dividing by here. I have no idea what it's going to do to the answer. I don't really care what's going to do to the answer. It's the process that's important. So we're going to cross this out, and we're going to divide by 2x minus 3 instead. Okay, just whatever that's just what I've chosen. I don't know why. I just want you to see what it looks like whenever we do this kind of a problem. Okay, so when we do long division, same process. Remember, I've already walked you through in the first two videos. This is going to be 2x to the fourth of the inside plus x cubed. Now be careful here. There are no x squareds. So this is one of the keys. Remember earlier in the first video I said the biggest thing to remember with this is that every power of x must be represented. Here's where we finally run into that. Okay. So I don't have any x squareds, but I need a placeholder for that. So I'm just going to say plus 0 x squareds. I don't have any, but I need to have a placeholder for that. If I don't do this, long division isn't going to work. I have plus x minus 1, and that goes on the inside of my long division sign. 2x to the fourths, x cubes, x squareds, x to the first, constant at the end. And then on the outside I have 2x minus 3. That's what we're going to divide by. We're going to move a little bit faster because I've done this already in the previous example, but the process remains the same. Okay, so if you need to pause or whatever at some point in the video, that's fine. Just try to keep up. Ready? I look at just the first term, the 2x. Ignore the negative 3 for now. Look at just the 2x compared to 2x to the fourth. Does 2x go into 2x to the fourth? It does. How many times? Well, the 2's already taken care of, so I don't need to multiply by any particular number. The x needs to go into x to the fourth. So it goes into it x cubed times. I need 3 more powers of x to get up to x to the fourth. Now I go through and I distribute out. X cubed times 2x gives me 2x to the fourth. X cubed times negative 3 gives me negative 3x cubes. I draw a line. I flip the signs, and I add. 2x to the fourth and a negative 2x to the fourth add up to 0. Perfect. X cubed plus 3x cubes gives me 4x cubes. I drop the 0x squared, and I repeat the process. Looking at just the first term, does 2x go into 4x cubed? It does. 2 goes into 4 twice. X goes into x cubed. I need 2 more powers of x. So 2x squared. Now I go through and distribute it out. 2x squared times 2x gives me 4. X times x squared is x cubed. 2x squared times negative 3 gives me negative. 2 times 3 is 6. X squared. Negative 6x squared. I draw a line. I flip the signs, and I add. These two add up to 0. 0x squareds add 6x squareds. I'm at here. I drop the positive x. I repeat the process. Does 2x, ignore the negative 3, does 2x go into 6x squared? It does. 2 goes into 6 3 times. X to x squared, I need an additional power of x. So I've got a 3x. Distribute out. 3x times 2x. 3 times 2 is 6. X times x is x squared. 6x squared. 3x times negative 3 would be negative 9x. I draw a line, I flip the signs, and I add. These two add up to 0. X and 9x add up to 10x. This turned out to be pretty convenient. No fractions. Now I go through, I drop the negative 1. I repeat the process. Does 2x go into 10x? It does, 5 times. The x's are already taken care of, so I don't worry about those. I just need the 5. Distribute out. 5 times 2x is 10x. 5 times negative 3 is negative 15. Draw a line, flip the signs, and I add. These two add up to 0. 15 and negative 1 add up to 14. Nothing to drop, so I don't worry about that. Does 2x go into 14? Well, here I have an x, and here I don't have an x. That's a higher power of x than this, so I stop. I'm done. That tells me then that this is my remainder. And so how do I write that I have a remainder then? My answer, I'm going to write it off to this side this time. My answer then is x cubed plus 2x squared plus 3x plus 5. And then how do I write that remainder? Just like last time, I say I have an additional 14 2x minus thirds. If you need to know how I wrote that, you need to go back to the first 2 videos and take a look, okay? Because I explain it in the first 2 videos, okay? So there's our answer. And what happens if I divide by 2x minus 3? Now, going back, this would not have been a synthetic division problem because it's not x plus or minus a number. It was 2x minus a number, okay? So now, when we get above this, dividing by this is synthetic division. Anything else, like this has to be done with long division is the best way to do it. And when we get up into the next video, the last video, and we're dividing by something like this, that's really going to be a long division problem, okay? So hopefully that makes sense. Hopefully you're starting to get the idea with the process, and we can go through one more video and just do a more complicated example. Looks like we might have to go to the back side of our paper, okay? There we go.